All right. Welcome everyone to the IPLD sync meeting. It's May the 4th. Oh yeah, on 2020. And as every week, we go over the stuff that we've done in the past week and then discuss any open items we might have. For the attendees, please put your name on the attendees list. Yeah, so I start with myself. So in the past week, I've done work on Rust IPLD on the blog API. I thought it was ready, and then I figured out that obviously also IPLD needs to be generic over codecs so that you can pass in your own codec table. Currently, IPLD just uses the codec table that multi-hash and CID provides. And that's kind of like a bigger change and probably needs a bit more of discussions with other contributors. So I will do this change first and then come back to the blog API. Then on the JSON spec, I opened a PR about making things clearer and tightening it down. There's currently discussion, and I hopefully we can resolve this and just keep the JSON simple, because it doesn't seem to be agreement on the base encoding of the CIDs. But yeah, hopefully we go for my preferred easiest solution, but we'll see. And on the multi-codec stuff, that's probably also one of Rod's items, is that finally Rod and I found agreement on the Filecoin stuff, that because they want to add new codecs to it. And the conclusion is pretty simple, that we still are not sure why they want to add 2 codecs for their stuff, but we trust them. Hence, we agree that they should add it to the codec table. We still hope to get an explanation on why it's really needed, but we'll see if this happens. So far, it hasn't. Cool. Yeah, that's all I have. Next on my list is Michael.
Yep. So got most of the multi-format stuff done. All the specs are implemented now. The CID stuff is there with all the breaking changes and full test coverage. Now we're talking about this binary stuff. I'm trying to figure out if we can drop the buffer API or not. It's looking like we may, though. So yeah, I'll stay on top of that. Next steps there are to port over all of the codecs and then port over the new block interface. So there's still quite a bit of work to get done. But yeah, the base interface is there and it works and it's pretty nice. So people should definitely look into it. Also made more progress on DagDB. So there's an indexing engine now. This is a really interesting data structure to build. That's been fun. Had to go in and add enum support to the schema validation library that I wrote. So that is now pretty much, I think, a complete implementation of the schema language, I'm pretty sure. I'd be missing a few corners here and there, but I think I got all of it now. And what was the last thing on my list? Oh, I also found a really nasty bug in the block API working on this stuff. Where if you were passing in just simple types that weren't embedded inside of strings and arrays, it was actually messing them up quite a bit. So that was really bad, and gotta release that for that. So that's fixed now. And that's about it for IPLD stuff for me this week.
Thanks. Next on the list is Eric.
So I have a giant week full of docs. That was about it. A bunch of it stuff that was started ages ago and just kind of languishing. The type theory glossary, which had a ton of comments from people in and out of this group, is now landed. Thanks everyone for comments on that. It was also terrifying to try to do any coherent doc about a summary of type theory in which we don't give too much credence to any particular terms, but still get super concrete and constructed. That was a really hard balance to strike. It's probably still not perfect, by the way. Not even a hope that it is. So if anyone has subsequent PRs on that, great. The library design recommendations doc is also merged. And I started doing a ton of example stuff. Okay, not a ton. I started doing example stuff in the Go IPLD Prime repo. So those are test files that are executable and also show up as examples in the documentation online. Probably going to need even more of those, but there's a start. I've been kicking around the link API design problem, which I guess is something that the JavaScript is reviewing at the same time as this too. I've been trying to solve for how to have a reasonable interface for links and at the same time not have overly concrete dependencies between the linking and the codecs and such things as this, so that the dependency tree transitively doesn't get out of hand. And the solution that I have for this in Go currently, it works. It doesn't have a dependency tree that gets out of hand, but it's also not very pleasant or terse to use. So like nobody's really happy with it, myself included. I've generated a lot more notes on that. If anybody wants to check them out, maybe they'll be cross-language applicable. I don't know. More effort still needed there in the future, I guess. The other piece of good news for the week is a bunch of other transitive dependencies of Go IPLD Prime have all now gotten on the latest generation where we've got the node assembler stuff. So that's exciting. That's about it for me.
Thanks. Next is Rod. Feel free to type later.
Yeah, I'll have to. So it's mainly been consumed with Bitcoin. The other thing first is the multi-format stuff. I'm going to note that in the doc. As Volker said, I think we've arrived at that. I think they're ready to merge, Volker. Just make that happen and make that team happy, I suppose. It's not entirely satisfactory, but I think that's reflective of this problem, which is we're tempted to make this satisfactory to our model, but so many of these different ecosystems that want to use these things are going to have their own models that don't necessarily overlap 100% with ours. And so I don't know if achieving 100% comfort is the best goal for multi-formats. So it's like, let's make sure it passes a bar, and then that's the sort of the minor threshold. And if they can justify it on their terms, then it's fine. So Volker and I did some talking about how to describe that and how we might describe that in some docs. So that work needs to be done as well. But yeah, 3 pull requests onto multi-formats to get the table updated. Then Bitcoin. So I found, I did a test across the blockchain with my code last week, I think it was, which was exciting at the time. But now that I realized that it actually didn't do a proper test at all. It was skipping over some things. And it also wasn't doing the full, I hadn't got it doing the full round trip that I needed it to do. So can I decode, represent the native structures, and then re-encode again? And so I did that last week, finally, the whole lot. So, and then I went through the blockchain. I found some edge cases, so I can now tell you all of the edge case blocks in the Bitcoin blockchain that have novelty in them. So pull each one of those out and put them into my test framework fixture set. But I can successfully do it for the whole lot now, which is good news. So that's a big step forward. And I'm working on the IPLD front end for this stuff, and I think what I'm doing is designing it for Michael's new whatever the thing is, the multi-format CID block thing that Michael's working on, new interface thing.
It's just multi-formats. It's just all of multi-formats instead of like one part of multi-formats. So we can just call it multi-formats.
Almost
but
all.
It's sort of, the block stuff is also bundled up in there as well, though. So basically trying to move away from the old API where you've got, you know, util and then serialize and resolve and this strange structure, and doing something a little bit more native to the new block API, so encode, decode, and whatever the third one is. Because I need to do that for at least 3 different types now. So I've got 3 different codecs for Bitcoin. And so that's the plan there. I think I've currently integrated my work into the old Bitcoin JavaScript library. I haven't put that on GitHub yet, but I think I'm just going to evolve that to the new stuff, put the other 2 in there, other 2 codecs in there, and make sure I've got a full test thing going on for that. And yeah, I think that work should go fairly quickly now that I've got the sort of the hard, tedious bit formatting work done. I'm actually right now I'm stuck on writing documentation. That's just taking a little bit of time, and yeah, looking after kids as well. So that's my week.
Thanks. Does anyone else have any updates? I have one thing I forgot to say that for the next week is that also basically, yeah, for people watching that, currently there's a huge interest in graph sync and also kind of related selectors, but it's really mostly graph sync. And I currently try to get all people together that are interested in implementing. So because like graph sync is also used in Filecoin and in IPFS, so there's interest from the Rust side of things on both sides. Also, there is interest on the JavaScript side from Chris. And yes, so just I try currently to collect all the people, getting them together, and then yeah, move forward so that there are not too many double efforts. And also things like, for example, I've talked with people about selectors that currently there's the reference implementation is in Go, and there is also tests in Go, but it's really like they're written in Go, and perhaps creating something like text test fixtures that can be used across languages and so on and stuff like this. So this should be the, yeah, what I want to get people together and then discuss and so on. So expect like, yeah, just tell me, and then I will make sure you are involved, and then yeah, I will post on all the issues where things are happening and so on. So that's kind of my plan. I'm not sure how soon this will happen, but it's probably starting this week and then going on to next week. But yeah, it's just, yeah, too many people are too busy. So we'll see how this goes. Yeah. Okay. Now we are up to questions or any other items. If there are no questions, I might quickly talk about the DAG JSON PR, because it looks like it's the beginning of a long discussion again. Currently, so DAG JSON is basically a format to just, yeah, mostly for debugging purpose. And currently, I want to tighten up the spec a bit. And I thought it would make sense that we just restrict the CIDs to base 64 encoded CIDs. The reason being that it's like base 64 is just like available everywhere, even in the browser. And it's super easy. And the problem there is you couldn't encode, for example, CID version 0 CIDs with it. But honestly, I don't see a big problem with it, because you can just encode your CIDs as CID version 1 and then transform it to a CID version 0 if you need it for your application. So I just want to like quickly see, like, could we, like, does anyone have really good reasons why we should support, like, for example, full base encoded CIDs in DAG JSON, and not just like base 64?
So I don't know if I want to claim to be the ultimate authority on this, but there's a bunch of APIs in IPFS that seem like they ought to have an opinion about this. Like, I think a bunch of DAG JSON is used de facto in a bunch of those APIs.
Oh, okay. That's a good point.
Wait. DAG JSON shouldn't be used anywhere in IPFS that I know of. There is a JSON representation of that they used to call canonical JSON representation of just IPLD that is like wrong, but it does exist, but it's actually not DEG JSON. That I know.
If that's the case, then I retract my comments. I don't know. It would surprise the heck out of me if there's nobody in the world who uses V0 CIDs in some sort of a JSON document. That just seems very improbable to me.
Okay, so basically, your concern is that you don't want to break IPFS. Basically, that's so. Basically, if
like the set of things that use JSON and CID V0, I cannot imagine that that's an empty set. That seems incredibly unlikely.
So this is one thing. This is a question that I have about CID V0. Is there a binary representation, or is it strictly strings? Like, are they always base 58, or is there actually a binary version of a CID V0 technically?
There is like the thing that you base encode as base 58 is the binary thing.
But do we do that anywhere is my question.
Yeah, for example, in CBOR, for example, you have the binary.
And in car files.
Well, but here is the thing, though. The decoded, so to speak, CIDV0 is literally a multi-hash. So with a lot of the conversations about, about storage changes and this and that, where we're going to use multi-hash only, this probably not directly, but indirectly somehow will clash with something.
My understanding is that those changes are intended to make this not clash. Like, my understanding is that the reason to go to multi-hash storage is so that if you have a CID V1 or V0 to the same data, you have the same underlying block data in storage.
Yeah,
right?
Absolutely. What I meant is that if in the store all you have is a multi-hash from kind of one code path, and from another code path you all of a sudden have this thing that used to be always a QM, but now is this binary thing that is also multi-hash, you might end up in a weird situation. I'm not saying I can see right now where the clash is, but it just gives me a bad feeling.
I don't know. The way that we support V0 is really hacky, like kind of everywhere. Yeah, I don't know what a good solution here is.
Yeah, but I just like as Eric mentioned, I think there is some JSON output from IPFS, and I think it's certainly using like the CID V0, of course, for the DEG PP API. So I guess that's a really good point, that it would make sense to support those, and then we need to support basically all types of CIDs. I would check the IPFS API and then go from there.
I think other people might be expecting that as well. Like, I'm trying to remember, and I'm sure I do not have a complete photographic memory of, but what the Radical project, for example, does. I'm pretty sure they're using a bunch of DEG JSON, and they might be expecting this code path to do things.
Yeah, I mean, like it's also like it's totally fine to do it this way. I just wanted, as always, like making the spec as like small as possible, so not having like all possible things. But if that's certainly used in the wild, which I wasn't aware of, then it totally makes sense to just say, well, it is / and then a base encoded CID, whichever base you want. It's fine.
Yeah, we might end up in general unit descriptive specs here rather than prescriptive specs.
You can't just do whatever base encoding you want, because then we lack determinism. The rule is going to have to be that if it's V0, it's base 58, and if it's V1, then it's a specific base encoding.
All right, if we want to, have, that's true. If we want to have it canonical representation, we have to choose one, but then But basically, if you want to have that, it doesn't make sense to support the CID V0 because you can also convert between them.
No, but you can't. V0 can only be represented with base 58 BTC. So
No.
you still have determinant. You still have determinism.
No, I mean,
if you want to do a round trip with the data, though, like that's my concern. That's my main concern here is if you want to be able to do a full round trip where 0 goes in and 0 comes out, you're losing that ability here. And it's the same thing with the car files.
No. Okay, I don't think you guys are understanding the rules. So the rule is that it's base 58 BTC encoded. That's the only way to string represent V0. Only, ever. And then you can optionally represent any V1 with any base encoding. But even if you were to V1 base encode a V0 CID, it would not match. So you're still preserving V1 or V0.
Yes, but you could convert a V0 to a V1.
But it's a different CID. That's different. That's not. That's actually a transform. That's a different block. That should be different data. It should be different hash.
Yeah,
that's
I'm just saying. I'm fine with. I like the idea of representing V0s as base 58 and V1s as base 64 because then you retain the round trip ability. But if you forced everything to base 64 and up-coded every V0 into a V1, you lose the round trip. So that any time you put a V0 in there, it just comes out as a V1 and you don't know what it was. You don't know if this thing was a V0 at one point. And I think that kind of information, that's the kind of information I think is more likely to be critical in some path that is much more distant from where we are. Like somebody right down the software stack that is relying on the fact of V0s. And then we're here saying, no, everything should be a V1. I think that's going to break too much stuff.
Another thing to keep in mind is that, like, people that are really trying to trim down their dependencies, now that we have this new multi-format stuff where you can, drop support for things, people are going to drop support for base 58 because it's the only base encoding that requires a big depth. So you're going to end up with cases where, like, even though we're supporting V0 inside of DEG.json, the DEG.json codec is going to throw an exception if you try to decode a base 58 encoded CID because people are just like not actually shipping that base encoding around. So it's not like we entirely get out of it. Like people are still going to stumble over this issue.
Okay, so basically then we use base. So we support for CID version 1, we only support base encoding, and for version V0, we just support the base 58, which is the only base representation we have anyway. Is this what we're gonna do?
That sounds
yeah. I mean, yeah, that's the only way to go. I mean,
so basically we don't support, because this is the big, or like could be the discussion point. We don't support base 32 encoded version 1 CIDs.
Well, okay. Yeah, okay. Let me think about this for a second.
That also checks out to me because I'm thinking of how this shakes out in the code in Go. And so the Go CID library, it has this structure for all of the additional metadata in the CID, and that includes the version and the multi-hash and the multi-hash length and the multi-codec, and it does not include the base, right? So, as it stands for all of the code that I have that depends on the Go CID library, which has been around quite a while and does not contain any of my opinions, by the way, then the base just isn't a part of what that is. So the base effectively does not fit into any of the data model and will not follow through there. And so overall—
No. It's still base. It's still multi-base encoded. It still has a prefix that tells you what the base encoding is.
Yeah, but the Go CID library does not, for better or for worse, and again, this is not my opinion, I'm telling you what somebody else's opinion was there. It does not preserve that.
So it just ignores the prefix and does whatever you tell it to do. You can't decode a string and just have it figured out.
But it does not retain the memory of what multi-base was used.
Oh yeah, no. The new CID library doesn't do that either. That was a terrible decision. Like, no, that's the right thing to do. Because what you want is you want like deterministic behavior out of the two-string API. So you don't want it to like, no, totally. I'm in agreement there. I think that like my skepticism about the spec here is like, one, if it's multi-base encoded, decoders are just going to pass that into a multi-base decoder and not actually check if it was improperly encoded. So in a similar situation to what we have with deterministic key sorting, we will end up supporting indeterministic behavior here on the decoder. We just need to like specify and try to ensure that all of the encoders do the same thing and do it deterministically. So what we're really saying is like the encoder should always use base 64 multi-base for V1, and then for 0 do the base 58 BTC. The last thing that I'm hesitant though is that we have gone through a lot of effort to make base 32 the default encoding everywhere. So like the default for two-string will return base 32 or base 58 BTC if it is V0. And that's been like a nice, really easy operation that you can do without checking anything. You're now going to have to check that and do base 64 explicitly. And I know that we're going to save bytes in the DEG-JSON format. It's just like we went through like a lot of pain to move everything to base 32 by default to make nice URLs. And I'm just wondering if like we should just eat the extra size and make it base 32 so that it's just consistent everywhere.
To me, the reason for using base 64 is basically that almost every language has base 64 support built in, or like standard library or something. So it's like it's super easy to consume the JSON or produce it, even if you don't have the full thing coded up. And base 32 you don't. So that would be my reason to do it.
Base
I don't know if
32
it's
does
important.
give some nice human readability.
I mean, base 32, the implementation of base 32 is like a very tiny function. I mean, the one in JavaScript, it doesn't take any dependencies. It's a very, very tiny function. And it's in the default set of base encodings because there's no depths.
I'm a little confused still though. Wasn't kind of one of the goals to not need people to pull in big number, whatever it is that you use in JavaScript to work with 256-bit numbers? Because you can do an actual, almost byte level transform to base 32 to base 64, but you cannot do so to base 58. You actually need to represent the entire thing as a base 256. And
that's what I was saying before about how one thing that you will find when people trim down the number of functions that they're shipping is that they'll get exceptions decoding or potentially encoding DEG-JSON if they're trying to use V0 because they won't have the base encoder there.
Exactly. So isn't one of the ways out of this is to actually define two fixed encodings? For instance, CIDB1 is always base 64 because it's just shorter, and a CIDB0 is always base 32, and that's that.
Yeah, CIDB0 can't be base 32. You can't do base 32 V0. You can only do base 58 BTC because and again, it's like a crazy hack, but
good point.
Because it was before we had multi-base encoding, so you can check if it's capital Q.
So basically, the discussion we currently have is to be clear that version V1 will be base 58 because there's no other way. And now we discuss should the version V1 be base 64 or base 32.
Right, but I mean, the point that Michael made earlier is essentially a no question, because if somebody needs to support CIDB0 in any shape or form, they need to have big num. Right?
I actually don't know if big num is one of the depths that gets pulled in. I mean, first of all, like we have big integers in the platform now. We have big integers in the platform now. The dependency that gets pulled in is called base X, actually, and it's like an
But
implementation of several base encodings.
You would need like in the current DAG JSON specification, you would need big num anyway, because we currently represent integers as big numbers in JSON. So just as an information. So we currently, so even besides the base encoding, you would need big number support in order to parse DAG JSON properly, which probably people won't do. But
really, how we doing that?
Is it big num in the browser now? Like I think it's been in the browser a little while now.
Yeah,
big numbers are pretty available.
Yeah, in your browsers, yeah. So, but yeah. Anyway,
so what does that mean, Volker? We use big num for representing integers. Are we putting them in quotes or something?
So the current specs. So the current spec says that. Do you know that JSON does make a decision on how big the numbers are? So we say put in any number you want into your JSON, therefore also in DAG JSON, and you need to make sure that you represent the number in your language, whatever it is. So basically, so currently, if you use a JSON parser, you can't parse DAG JSON natively, basically, because there might be a big integer number.
Oh, so this is just in case there's a very large integer. Okay.
Yes.
I mean, the way I've been dealing with that is just saying, essentially having a path where it's like, okay, do you want big number support? Well, then you're going to have to opt into stuff, but you can parse this stuff natively. It's just that you may not get big numbers out of it. So it's like you have to opt in as a consumer of these libraries. If you want that hassle, then. Yeah, it's like the CID version 0 thing. If we can make that pluggable, do you want CID version 0 to be supported or throw exceptions? Well, it's up to you.
Yeah. So Peter, what was your point? No, I was asking, what was your point about the big number and stuff?
That literally like what Rod just said, that it almost seems like just the way basically CIDB 0 right now is equivalent to a big num dependency almost. And yeah.
So actually, this is the way that we should probably change the spec. But like in general, all of the codecs need to round trip without any loss of precision or change in the hash. So you should be able to always decode and then encode again and always get the same thing. So that has implications on ordering in maps, and it also has implications in JavaScript for number representation. Because if you round the numbers, then you're not going to get the same hash when you re-encode. That's the problem. So like if we're not saying how you have to parse that in order to preserve the number. We're just saying that like your encoder and decoder need to reliably produce the same thing, even when you have really large numbers in JSON.
Right, either that or throw an exception that I do not support that.
Right.
Okay, coming back to the base encoding. So, I mean, I don't care if it's base 64 or base 32. I'm fine with both. I just thought like base 64 is more. So, basically, okay. The point is why I also want to do base 64 is because we encode binaries as base 64. So you need a base 64 encoder for that one anyway. So I thought, well, it makes sense to also base encode the CIDs because, well, we have that anyway.
Yeah, I mean, it's fine. It's fine. I was just considering it. Because we are trying to default.
JSON does have this nice property that you can print it in a human readable form, and if CIDs were base 32, then they would be much more recognizable.
I don't know, that's also going to make the line huge though. So I don't know how much more readable that it is when you consider the wrap on the line.
But you don't for the size of a CID, like you're going to save like 10 characters, no, 5 characters at most.
It's more than that, but
it's noticeable. It's noticeable.
Yeah. Oh, it's 7 characters. Is that right?
No, it's more than that. I think it's like 11 or something. But more to your point, Rod, they're not only human readable. Most gateways and local installations and whatever support subdomains as CIDs base 32 encoded. With base 64, you cannot do that. So you can literally
but that's not
stuff into a browser.
In a
your
JSON document,
console.
that's not necessarily, in DAG JSON, that's not really our concern though, because that stuff gets hidden.
Yeah, no, it's
So
not a concern,
what-
but it's nice.
So
Right,
what the trade-off that we'd be making is that we'd be eating bytes in the block format for saving base encodes when we do stuff with them later, because that base encoding does get cached when it gets parsed, so we never actually have to generate it again. So there is like a slight efficiency gain on the compute side, but we're literally adding bytes to the block format to do it. So I don't know if that's worth
Don't
it.
talk about efficiency when you talk about DAG JSON. Like DAG JSON is not a format. Like, that's not the point. Like that's not the point.
Also compression is a thing, so it doesn't really matter.
So like
does it?
that's totally the point. To be the point about DAG JSON is it's a format that represents the data model, and you can use it mostly, I guess, for debugging purpose or for exchanging on platforms where you don't really have like a CBOR encoder or something. So basically limited platforms, and therefore I think it makes sense to basically strip down the dependencies on like external things you need. So if you need already a base 64 encoder for decoding binary, you have that already. You wouldn't need to have another base encoder for your CIDs. You can just use the same one if you want to decode them. And if you don't want to touch them or decode them, well, you don't need the decoder anyway, so it doesn't matter if it's base 32 or 64.
Yeah.
This will be my point, but I mean, yeah,
it could. I can just imagine it getting annoying where you've got DAG JSON data and you're debugging or you're looking through stuff and you're coming against these CIDs and you have to pull them out and decode base 64, re-encode base 32 just to see what CID that is. Like you'd have to. It's like then it becomes like dealing with CBOR where you have to pass it through a parser to get to things.
That's actually a good point. Like because like I guess in the future you will be used to base 62 encoding. And and if you debug, you can see like, oh, okay, it's the CID, and then I can see that point. Good point. Also,
the base 64 and base 32 encoder decoders are insanely small, so it's not actually much of a worry in terms of like bundling and requiring. So I'm not as worried about taking extra ones on, except for base 58. That's the one that's actually like a real pain.
Can we make that not a pain? I haven't looked at the code for that, but it's not that big a deal.
Okay. Yeah. Okay. So do we then use base 32 encoding for the CIDs?
Yeah, that makes sense too.
Okay. I mean, like also like the binary. So again, thinking about like how DAG JSON is used, you probably don't ever decode the binary stuff. Like you see a base 64 encoded string, but you don't care about it, probably.
Yeah.
From a like practical perspective. So.
Well, I mean, when you decoded the block, you automatically decoded into a buffer.
No, I get your point though. If you're debugging something, then you're not going to be looking at that, so it doesn't really matter.
Yeah. Okay. So we think, then I will make a PR on the spec saying that CID version 0 is base 58 encoded. CID version 1 is base 32 encoded, multi-base encoded. Yeah, and that's it basically. And then you have a canonical representation of your DAG JSON because it round trips. Yeah.
Cool.
Okay. Cool. Thanks. So I guess this saved about like 2 hours of everyone discussing it on GitHub, I guess. Okay. Yeah. Cool. Yeah, I will do this tomorrow. Cool. Thanks for your time on like discussing this. Yeah, that's pretty cool. Good. All right. Anything else?
Mike, sorry, just to continue this thought, Michael, I think that, so just looking through the base encoding stuff in JavaScript, you can see that there is we have a fast path for base 64 and base 32 because that's fairly easy. But for base 58 and the other novel bases, we have to go and use this base X library, which is not huge, but it's another dependency. I just wonder whether it'd be worth us implementing our own minimal base 58 BTC encoder just for this case, where if you want to support, because there's so many places where you're going to still want V0 support and it should be as easy as base 32 and as native. So maybe we should work on implementing our own fastpath base 58 BTC to plug in. And then if you want more bases, then
I think there is already one. I think it got removed with a more general one, but I think there is one already. I think it's called BS58 or something.
I'm sure there is, but if we can just embed these things in our libraries, like it just seems like base 32 and base 58 BTC are just going to be around forever for us, and we should just swallow that fact. And if we make everything else pluggable with those two things, if we can make compact representations that we just ship around with everything, I don't think that's unreasonable.
Yeah, also the base 64 implementation could probably actually be sped up by using the browser default functions in the browser. Like right now it's that function implementation, and I bet it's quicker if we use the BTOA. But.
Anyway, I mean, this is worth looking at now, Michael. You're making your stuff more pluggable. Let's look at these common cases versus uncommon cases, and what can we ship natively that's fast and compact.
Yeah, I mean, so I'll put it this way: we can just ship the multi-format stuff as is. There's already a base 58 implementation in there that requires that depth. It's just obviously it's not loaded in by default or anything. There is a basics file that is like the multi-format /basics, which is just like a reasonable set of defaults that don't have any dependencies, and it's not in there. If we replaced it with one that didn't have any external dependencies, then I would just add that to the basics set so that we had base 58. Most people would just have base 58 at that point.
Yeah, so basics is everywhere, as Volker's finding out, which is not bad. It's not huge dependency, but it's written to be generic, and maybe we don't need generic for this case. And if you opt into special cases, then maybe you get generic. Anyway, probably not worth dwelling on too much here.
All right. Anything else? No. Then thanks everyone for attending and everyone for watching, and we see us again next week. Then on time. Goodbye, everyone.